We're here in DPI's fireproof lab addressing the problem of dryer fires. We've installed an electric dryer here. We know from statistics that we've had approximately 412,500 fires per year, and of those approximately 12,000 are dryer fires. These statistics are gathered from a variety of sources, so the statistics may vary to some extent depending on the sources that you're checking. We've set this dryer up, and the dryer's been altered a little bit. We've put in some ports. As you'll notice, we have cameras mounted on both sides. These cameras are looking at the operation of the dryer as it functions. We also have an array of instruments set up here. Each of these instruments are reading a temperature at various locations on the dryer. The dryer is cool to the touch. It has not been operated. We've also connected our vent. And we have some streamers on the vent to show that we have air movement. We have the capability of shutting the vent off completely, and we'll do so later in the video here. It's important to look at one of the main features of a dryer, and the main causes the fire's been concerned, is that the heat trap, or the lint trap, is properly cleaned. As you can see, this lint trap has been cleaned. A variety of lint gathers in dryers. We have gathered some of that lint. The lint comes from different style clothing, whether it's cotton, nylon, rayon. We'll throw some of this lint material in the dryer to add some additional flammability potential there. We'll also, for this example, we will put in some terry cloth towels. We find typically that when a dryer, the clothes come out of the washing machine to enter the dryer, they contain about 1.5 pints of water. So we have 1.5 pints of water measured here. And what we'll do is soak some of this water into these towels. We've shut the machine. We'll set it on a normal dry cycle and start the process. We'll be monitoring these temperatures as we go through the tape to identify the heat cycles as they transpire in and out. As you can see, we've got air movement out of our vent. We have two thermostats. We have an operational thermostat and we have a high limiter thermostat. If the operational thermostat should fail, then the high limiter thermostat is designed to cut out the temperature progression so that you will not reach above a flammable point. All dryers will collect lint in them as they function. Just part of the process of drying, it occurs. It's impossible to stop. The dryer will collect lint in the motor compartment. There's no way for the consumer to get into that compartment and clean it. Even professional cleaners that have been retained to come in and clean these units do not open up the cabinet and clean that lint. They'll clean the vent path, they'll clean the airflow path, but they don't actually clean down around the motor housing. We talk about at what point will lint ignite. If you put lint against a heated source, not an open flame, but a heated source, we found that it typically takes over 900 degrees to ignite lint. And at that point it will really not ignite, it will start to smolder, it will melt the material almost, and it will form a hard ball. Open flame, again, depends on what type of material. Rayon, nylon, cotton, different fabrics and synthetics may ignite quicker to an open flame than others. Interesting, these electric dryers, there is no open flame. There's heated surfaces. How does the lint get into the heated surface that accelerates beyond 900 degrees? Shouldn't. The coils and that and so forth may run that temperature, but they should be in a sealed unit where lint can't get to them. So we're now up to about 208, 209, and we're climbing. Now realize that's the temperature of this cabinet. If you was to put your hand back here, you're touching a heated surface that is now at 215 degrees. There's a rubber power cord that supplies power. This runs on 220. So that rubber power cord, if touching the back of the unit, is sufficient to cause melting of the rubber, which can result in a short. An electric arcing, that arcing can cause a fire. Again, it just depends on the location, the installation. As you see, we're continuing to climb. We're now at 220 230 degrees and climbing. Our internal temperatures are running about 159 to 125. The high limiter thermostat should kick out at about 167 if everything is functioning properly. So every time you have a dryer fire, you have to think about all the different potentials. What caused that fire? What failed in that unit? What temperatures were reached with that unit that caused ignition? Now, one of the things you'll notice, we're not blowing any burning material out of our vent. They often talk about lint being ignited and the lint being ejected through the vent and the vent catching fire. That's not occurring. Even though we're at 283 degrees on the exterior of the cabinet, and we're heating inside, we're at 183. We're at 296 degrees. I have no doubt that we will exceed over 300 degrees. This is considerable temperature that if you had a piece of clothing hanging over the dryer, if anything fell behind the dryer, there's potential for fire. Now, nobody's done anything wrong here at this point. The consumer has cleaned the lint trap. The vent pipe is completely open and operational. We have no difficulties whatsoever with it. And the dryer is functioning. We're now at 304 degrees. You know, how hot will the exterior of the cabinet get? Depends on the amount of moisture in the cabinet, how long the thermostat calls for a continued heat cycle. What causes a fire to occur? Often the claim is made that if you interfere with the airflow in the machine, then the temperatures will elevate rapidly and you'll have a fire. Well, we can talk about that. We have the ability to put a gate valve in our airflow and stop that airflow from happening. And do we have the potential for fire occurring? We'll control the airflow by sliding this shield in there. If you'll notice, we have shut the airflow off completely. There's very little movement in the vent. Okay, and what's occurring? If you took a 4-inch pipe and you squeezed it down to where you had a 3/4 inch hole, that's the amount of air movement. So you've got 3 3/4 inches of solid lint blocking your vent pipe. Now this effect is going to affect your drying time because the air is not moving through the drum like it should. But it did not affect the operation of the machine. The machine is operating properly and safely. Our temperatures on the plenum has dropped to 171 degrees. Our temperatures on the back of the machine has dropped to 259 degrees. And the machine is functioning as it's meant to function. Now we can unblock the vent, allow full airflow movement, or we could allow 50% of it, and you'll see that the machine is starting to reheat. We're up to 46, 45. We're still drying. Our thermostat has not kicked in yet. So we'll watch. As it cools down, your temperatures will start to return because the heat cycle will start to regenerate and produce heat. As you see, the heat is coming back up again. Now we're back up to 152, 154, 156, and these are climbing back up. The outer cabinet now will kind of stabilize because we're into the heat cycle. And you'll probably stay pretty close to that 200 degree temperature. We're up to 174 here, 176. So that tells you your thermostat has re-energized your heating coil. You're now producing heat. It's important that adjusters understand every dryer fire has a reason why it occurred. Something had to go wrong. If the machine is operating properly, even though you plugged the vent completely, even though you have high temperatures, you do not get ignition. Something has to go wrong. Something has to malfunction. Either high limiter thermostats are not shutting down, or there's flammable material in the design of the unit. Something in there has resulted in an ignition source. This something needs to be investigated and determined why, so that you can make a determination if you've had a product failure. As we operated the dryer, we checked it prior to starting and we seen that the lint trap was clean. We did put some additional lint in the machine, and this shows you some of the pieces of lint that have been circulating in the machine. And you know, the question came as, did the fire occur because the lint trap was not properly cleaned? Here's what our lint trap looks like. And as you see, the lint pretty well blanketed the lint filter. I think if the lint was the cause of fire, then there's more than sufficient lint here to produce that effect. So we have to again ask ourselves, what is the cause of the ignition? What is the source of the ignition?